Thanks so much, Felipe. I'm Sean Kimmel, Director of Engineering at QS-2, and we're excited today to talk about our capabilities, both broadly and UAM specific. My doctorate is in systems engineering with a focus on robotics and automation. I had the pleasure of working on the DARPA Urban Challenge, which is one of the initial works into developing automated driving systems for the roadways. And to round out the discussion today, I'm joined by my colleagues, Chris Fernando, Colleen Reike, and Jeremiah Robertson. Thanks. Over to you, Chris.
Thanks, Sean. Hi, everyone. My name is Chris Fernando, and I'm the principal of aviation at QS-2. I'm new to the firm. We are growing, a fast-growing firm with a focus on transportation and aviation. And my background for the past 20 years has been in the airports and aviation space. I had the privilege of leading a urban mobility study for NASA and some other research on integrating UAS into airports and the NAS. And I'm happy to take part in this Skyscraper event with my colleagues. And now I hand it off to Colleen.
Great, thanks, Chris. I'm Colleen Reike. I'm the lead scientist in the aviation team at QS-2. My background is in aviation weather, data analytics, and research. I have a PhD in atmospheric science and a little over 12 years of experience in general aviation research, as well as specializing in aviation weather. And also had the privilege of helping Chris lead the UAM market study that was conducted a couple of years ago for NASA ARMD, essentially looking at the broader ecosystem and some of the key challenges and barriers facing UAM. So looking forward to this discussion today, and I'll hand it off to Jeremiah.
Thanks, Colleen. Hi, I'm Jeremiah. I'm an associate engineer here at QS2. Really excited to be a part of the Skyscraper discussions. My educational background is a master's in aerospace from MIT. My background's primarily focused on safety, so that's my primary research interest. I've worked on different projects with the Air Force Research Laboratory and evaluating autonomous systems and evaluating manned-unmanned teaming and how drones can work together with different fighter aircraft, and worked on different DoD programs with the Air Force, like F-35 Joint Strike Fighter and different nuclear weapon capable aircraft like the B-2 and B-52. So with that, I'll hand it back over to Sean to start our presentation.
Great, thanks so much, Jeremiah. QS2 is a technical consulting firm with a focus on emerging technologies. We've been steadily growing since 2013 with an unwavering dedication to our clients and our people. We provide career opportunities, competitive benefits, and research facilities, tools, and equipment. We hire, maintain, and retain experienced professional staff that provide high-quality service to our clients. For example, we have 90% of our researchers have PhDs, and 60% of our staff have over 20 years of experience in their field. We continue to grow our client base and hire personnel to tackle challenging problems in specialized technical fields. I wanted to spend a few moments on our core capabilities, which you see here. We have a team of data scientists that bring a toolbox of statistical and machine learning algorithms to new and exciting problems, especially those focusing around big data, and use these techniques to develop actionable recommendations. For example, we were recently selected by the Office of Naval Research to conduct research into advanced capabilities to identify bots, human propagandists, purveyors of disinformation, and other malicious accounts in social media. We also have decades of experience in biotechnology. For example, we're currently researching the use of DNA as a data storage medium. We also have a team of passionate transportation professionals with backgrounds in aviation and ground transportation. We'll be covering more of the aviation practice today, but I'll share a few projects from the surface transportation business to give an idea of our capabilities. We're currently working a project with NHTSA, which is the automobile regulatory agency within the Department of Transportation. We're studying the technology and market trends surrounding automated driving assistance systems, driver monitoring systems, and connected vehicles, including looking at the influence of consumer trust, in-cabin passenger experience, and willingness to pay on the market penetration rates of these technologies. We're studying considerations related to sensor performance, disuse, misuse, abuse of technology, supply chains, testing evaluation, and operational safety. We're collecting this information through research reports as well as primary sources through focus groups and surveys. Another example of our work is to develop safety frameworks, metrics, and methods for automated driving systems. We're developing best practices with the Automated Vehicle Safety Consortium in those areas, and recently published a best practice on data collection for safety event analysis. We bring a collaborative approach to addressing multidisciplinary problems. For example, we recently completed research at the intersection of all three of these capability areas, where we analyzed existing data sets to look at the costs and benefits of using UAS technology for COVID response, and using biotechnical understanding of the medical domain and the needs of the consumers of these transport of these products, the data analytics of existing data sets, and understanding of the transportation system in which those UAS are operating. So with that, I'd like to hand it over to Chris to provide some more background on our transportation capabilities and aviation functional capabilities.
Thanks, Sean. So as Sean alluded to, we have a very fast-growing aviation team in addition to the transportation capability. While today's focus is on UAM and UAS, I wanted to highlight some of our expertise in other areas. In particular, we have extensive experience in air traffic management, air traffic flow management, air traffic operations. Weather, as Colleen mentioned, is an area of our expertise that we focus on for FAA and NASA. And in my previous background, I supported FAA with several airspace redesign projects. Jeremiah is a safety expert with a background in software development, and of course the airport experience that we bring to the fold with several master planning efforts at airports over the course of the past 20 years. I'll touch a little bit on the UAM piece before Colleen dives into the more robust outlook on the market, as well as some of the barriers. UAM is not new to our industry. It has been evolving over several decades. And as you can see, in the 1950s, New York Airways started out by providing services at the airports from Manhattan to LaGuardia. In the 60s and 70s, Pan Am had a service which was essentially last mile to the airports, to JFK, between Manhattan and Newark. And in the 80s, Trump Air provided helicopter services that were similar to what is kind of evolving into the eVTOL UAM market currently. And in the 2010s, we had increased interest in things like smaller jets, smaller GA jets, and now we have come to the time where we are starting to evolve the discussion, the research, and the technology into the urban air mobility and unmanned system space. So as you can see in this decade and onwards, projecting forward, there's a lot of exciting things happening in the UAM space. For example, Toyota, Hyundai, and other car manufacturers are heavily investing into this space. EHang out of China has advanced their 2 platforms, moving medical packages and people, especially during COVID. And of course, the Department of Defense in the United States has a large and very exciting program called Agility Prime that's looking at urban air mobility vehicles in the DoD space. And as we project into the future, 2023 and beyond, NASA has a nationwide campaign to continue to maintain our leadership, the US leadership in urban air mobility, to help the industry, both government and private industry, to evolve the industry and bring this aircraft and services into the airspace. And then 2025, that program is going to help scale up operations through operators like Uber and others. And these use cases, as they mature, we expect them to become air taxis, air metros, air ambulances, and a host of other use cases that I, as an aviation person, and my teammates are really excited to support our clients at FAA, NASA, and our commercial clients in the US and internationally. With that, I'd like to hand off to Colleen to continue our presentation.
Great, thanks, Chris. So kind of pivoting into sort of the extended market outlook for UAM. So as Chris mentioned, there's a lot of activity, there's a lot of engagement, not only in the United States, but internationally, and dedication into UAM. There are an extensive number of potential UAM use cases that range from passenger mobility to emergency response and goods delivery. And we've even seen some new use cases evolve as a result of the COVID pandemic, such as sanitation of public spaces, as well as medical delivery. There are also more than 250 vertical takeoff and land, or VTOL aircraft, as well as electric rotorcraft that are under development, essentially to meet the needs of some of these use cases. And there's a few examples shown on the right of this slide. And according to the UAM market study that both Chris and I referenced, and several of us here on the QS-2 team supported several years ago, this market analysis found that a potential best case unconstrained market value for the passenger air taxi use case could be about $500 billion, which is pretty substantial. But do definitely want to note that the unconstrained scenario essentially indicates that there really are no limitations. So a passenger would be able to board one of these aircraft at any location, fly to any location they want to, and not have to worry about time of day, volume, weather, anything like that. But of course, we recognize that there really are a myriad of challenges and barriers that will reduce that market potential in the near term, such as legal and regulatory, aircraft certification, public perception, weather, et cetera. And essentially, after applying those constraints, we found that only about $2.5 billion of that potential market could be captured in the near term. But as Chris indicated, there's significant dedication within industry, government, and companies to help UAM succeed. So a lot of these constraints can be addressed, and really are actively being addressed through things like ongoing intragovernmental partnerships, government and industry partnerships and collaboration, and really events such as Skyscraper, and engaging and having the broader community engage in some of these discussions and help create partnerships and synergies to address some of these challenges. So now looking at sort of the broader ecosystem, as I just mentioned, there are a myriad of challenges facing UAM. And we've sort of characterized them according to those that will primarily be facing the near term or more immature market, which are shown on the left here, and those facing longer term, more mature market on the right side. And we can also categorize these according to those that are either related to technology or could be addressed by technology, which are the ones shown in the top row here, as well as those that are not related to technology, which are the row at the bottom. So starting just at the top left, kind of walking through a few of these examples, I won't go through in detail. I realize there's a lot of information here. But some of the things related to technology in the near term are high cost of service, and of course, adverse weather, which affects really every element of aviation and will also affect UAM. Air traffic management, so high density operations are going to strain the current air traffic management system as these operations scale up. Battery technology, we found can definitely be a limitation. Things such as battery weight, long recharge times can really be detrimental in the near term. And also community acceptance. There can be some adverse and energy and environmental impacts concerns, particularly with noise. But of course, as we look to the long term, some of these can certainly be addressed, but we're also going to see the emergence of some new potential challenges. So for example, cybersecurity is going to, I think, evolve in a major way with potential impacts to autonomous systems. Weather is going to continue to be a disruption in the long term, sort of regardless of what happens with the technology. Air traffic management is going to continue to be impacted. It'll just more than likely evolve from the current air traffic management system to having to deal with other large scale operations, things such as commercial space, UAS, et cetera. And then from a community acceptance perspective, energy and environmental impacts such as noise will continue to be a concern as these UAM operations emerge at a larger scale. In terms of the non-technology challenges, looking in the near term, infrastructure is of course one of the key challenges, both the lack of existing infrastructure as well as the low throughput of that infrastructure. Competition, of course, from existing modes of transportation. Weather conditions can, of course, impact the non-technological aspects of operations, such as the infrastructure. Public perception, we found that passengers are very concerned about safety. They have preferences for security screening and only using UAM for longer regional trips. Laws and regulations, at least in the United States, are going to be needed for operations flying over people, beyond visual line of sight, and for those carrying passengers, among others. And in terms of aircraft certification, there are some significant gaps in the existing certification framework, particularly in the areas of system redundancy and failure management. And then again, some of these can and will be addressed in the long term, but some will remain and some new ones may emerge. So of course, competition is going to remain. It's just going to be different modes of transportation, such as autonomous cars and fast trains that will represent the competition in the long run. Weather will continue to be an impact, and some elements of that could actually be magnified due to climate change in the longer term. Social mobility, and I think this is something we're even seeing with the COVID pandemic, that different levels of importance of travel time, increase in telework, things like that can create challenges and barriers potentially for UAM, but can also potentially elevate other use cases for UAM. And then of course, public perception is going to remain a challenge, and we found that there are some significant trust and apprehension challenges related to pilotless UAM, whether that's remotely piloted or just not having an autonomous UAM, and a preference for passengers wanting to fly with somebody they know and not with a stranger. So again, there's quite a few challenges here, but we can definitely work to address them. So now I want to talk for just a couple minutes here on some of the initiatives and some of the work that QS-2 is doing in this space. So one area that we're focusing on is on that passenger acceptance challenge that I talked a little bit about in the previous slide. So specifically, we are supporting a phase 1 NASA Small Business Innovation Research, or SBIR, partnering with Crown Consulting. And in that project, we're essentially designing a human-in-the-loop experiment to assess the impacts of UAM vehicle ride quality on passenger acceptance. So essentially looking to design an experiment test matrix that includes key ride quality variables such as vehicle motion, cabin noise and vibration, as well as secondary variables such as the presence of a pilot, the temperature of the room, as well as the virtual out the window view. We also will be looking to capture and measure passenger response, both perception-based as well as physiological, with things potentially like eye tracking and heart rate monitoring, and then ultimately relate that back to passenger acceptance and their willingness to potentially fly in a UAM. So designing that experiment as well as the data analysis plan to essentially understand the relationship between those last 3 boxes I'm showing on the bottom. So another area which I mentioned previously, and then Chris also touched on, that's really key is addressing some of the potential weather impacts. And weather can really extensively impact the UAM ecosystem. I briefly mentioned this before, but I think it's one of the unique impacts that can really kind of creep up everywhere. So you can have impacts to the operations, you can have impacts to the infrastructure, community acceptance, air traffic management system and procedures, et cetera. And the existing aviation weather observations and forecasts that are routinely generated to support commercial aviation really lack sufficient coverage and resolution, both spatial and temporal resolution, to fully meet the UAM needs. A lot of these observations are focused on airports, they're focused on higher altitudes, and we really just don't have that data to support operations in and immediately around urban areas. And according to the UAM market study, where we did a sort of deep dive quantitative assessment, looking just at surface weather, so really only looking at a component of the overall picture, found that a large portion of the UAM operational day could be impacted by weather in 10 focus US cities. So we at QS2 are very dedicated to working with industry, working with government to help better elucidate some of these challenges, as well as identify and address some of the broader research needs to address these impacts. And one noteworthy group that we are co-leading and actively participating in our monthly NASA Community Integration Working Group weather subgroup meetings. So this is part of a larger effort that NASA is conducting, where they have several broader UAM working groups, and this one is essentially dedicated just to UAM weather. And some of the past topics have focused on the need for a dedicated UAM weather testbed, as well as the need for UAM weather standards. And speaking of weather standards, another area that QS2 is actively engaged is contributing to the development of UAS weather standards for the ASTM F38 committee. And that is ongoing, and we expect some of those standards to begin to evolve and be reviewed in 2021. And then from there, I'm going to hand it over to Jeremiah to talk a little bit about safety management systems and the need there and what QS2 is doing in that space.
Awesome, thanks, Colleen. So this is an interesting research area that we at QS2 are starting to explore and dive into. So this diagram that you're going to see here on the left, the monitor, assess, and mitigate components of this in-time aviation safety management system come from the report you see at the bottom, the National Academy's report that was published in 2018 that addressed a lot of the challenges and some of the research that's happening with respect to SMS within aviation. So what QS2 is bringing to the table in terms of in-time aviation safety management systems is identifying components that can go into each of these different areas and evaluating what is a solid framework that we can start to base IA-SMS off of. So that's really what we're trying to focus on now. So you'll see there for the monitor component, we have different pieces that need to be plugged in there. And some of this commercial airlines are already doing, for example, accident analysis. Every time, that's why CAST exists, is to go evaluate accidents after the fact and evaluate contributing factors. They're performing data monitoring, change management. Obviously, there's virtual modeling and simulation and physical testing that happens. But then, so one of the keys here is under the assess component, part of the framework that we're providing is this ability to proactively identify hazards within the national airspace system using this three-step approach. And so the key here is that the word proactive. So what happens now is there's a lot of data monitoring that happens. And one of the inherent assumptions is that future accidents are going to be similar to accidents that have already happened. So essentially we're monitoring data, and it could be swim data, FOGA data, you name it, but it's we're monitoring that data because it is shown in the past that an accident has occurred due to XYZ parameters and their exceedance or whatever it is. But what we need is a framework to proactively identify hazards, and then you can use the data monitoring to analyze trends based on parameters that are significant based on this framework, not necessarily ones that may have led to an accident in the past, and not necessarily based on failures either, because many times, a lot of the accidents that we see in aviation aren't necessarily the result of failures. You could have mental model flaws, you could have environmental parameters that pilots weren't aware of, autopilot they thought was on and it wasn't. So a lot of times it's not necessarily a hardware failure. Can be several contributing factors to a given incident. And so that's why it's important to have this type of framework in place as we start evaluating hazards, especially as UAM vehicles start to enter the national airspace system. This is critical. And so how we do that is, so step one's inspecting the hazard analysis. So we use a systems theory-based approach for hazard analysis and analyzing how accidents and hazards are the results of different contributing factors within a control structure, and then analyzing different scenarios that may result in unsafe control actions taking place. And then really the critical piece is this analyzing assumptions here. So by tracking assumptions within the national airspace system and how they are modified over time or violated over time, that's really how we maintain the proactive approach. Is whenever those assumptions are violated, that is a big red flag that something has changed and that we need to run through this process and evaluate whether or not the assumption still holds, and if not, what mitigations are needed, and to be able to update the assumptions and the hazard analysis based on those changes. And then all of this is done using a human-in-the-loop methodology. That's really important because a lot of times, we like to have these automated tools that can kind of tell us, hey, this is wrong, you need to look at this, and then automatically provide us the mitigations and tell us how to fix it. But we're really focusing on the human in the loop because it's critical to have the human involved in understanding what the machine is doing. So finding that critical balance of kind of the human machine interface and the interaction that happens there is an important part. We don't want to just eliminate the human altogether. I mean, obviously that would be great because machines are very fast, but we think it's really critical to include the human as part of this methodology, and helping the software, and the software helping the human, be able to analyze trends in the data, analyze what assumptions might be violated, and then identify the best possible mitigations. And then finally, in the mitigate component, we've set up different communication channels that are possible to be able to report back what the updates are in terms of new procedures that are necessary, new systems or machines or tools that might be required. All of that, I will hand it back over to Sean to close this out.
Great. Well, thanks so much, Jeremiah, for taking us through the different methodologies for assessing safety of these systems. Thank you, Colleen, for taking a look at the different market factors and technology factors that are going to really govern the deployment of the technologies. And thank you, Chris, for talking through the different aviation capabilities. And thank you, Felipe, for organizing this. We've really enjoyed the opportunity to get to share with you all our capabilities, and we look forward to continuing the discussion. Please don't hesitate to reach out with any questions. We look forward to continuing the discussion.